Hello, classmates! In this lesson, we will begin learning about the types of substations. In this lesson, we need to grasp the basic concepts and types of substations. It is hoped that through this lesson, you will be able to accurately analyze the characteristics of various types of substations. At the same time, through this lesson, we will further cultivate a spirit of dedication and job commitment, develop a diligent and detail-oriented work attitude, and enhance safety awareness and teamwork consciousness. The key and difficult points of this lesson mainly focus on the basic types of substations. When it comes to substations, what is your impression? Is it steel structures standing like forests, or overhead lines intertwined like a net? Actually, these are the most common types of substation. Its professional term is outdoor substation. Of course, there are also indoor substations and semi-indoor substations. Well, today, let us get to know these substations together. A substation is a site where voltage is transformed. It is a connection point in the power grid used to transform voltage, exchange power, and collect and distribute electrical energy. Substations consist of distribution devices at different voltages, power transformers, control, protection, measurement, signal, and communication facilities, as well as secondary circuits and power sources. Therefore, it is also called a transformer substation. Next, let's look at the types of substations. Substations can be classified into different types based on different criteria. First, according to the installation location, they can be divided into outdoor substations, indoor substations, and semi-indoor substations. Next, let's watch a video together.
Common types of substations. When it comes to substations, what is the first thing that comes to mind? Is it steel structure standing like forests, or overhead lines intertwined like a net? Actually, this is only the most common type of substation, whose professional term is outdoor substation. In contrast, there are also indoor and semi-indoor substations. Today, let us properly understand these several types of substations that are closely related to everyone's electricity usage. As mentioned earlier, an outdoor substation refers to one where the main equipment is basically arranged outdoors. Its characteristics include a large footprint, electrical installations and buildings that can fully meet various distance requirements, such as electrical safety clearances and fire separation distances. Heat dissipation is also very convenient, and the cost investment is relatively low. Operation, maintenance, and inspection are all very convenient. Substations with higher voltage levels generally adopt an outdoor layout, considering its advantages of economy, convenience, stability, and reliability. As the name implies, an indoor substation refers to one where the main equipment is placed indoors. Indoor substations reduce the total footprint, but have higher requirements for the internal layout of buildings. They are characterized by compactness, large height differences, and varying floor height requirements. Sometimes, specialized aesthetic improvements are made based on the surrounding environment. They are suitable for urban densely populated areas or areas with high air pollution levels such as coasts, salt lakes, and chemical plants. Currently, most newly built 110 kV substations in main urban areas adopt an indoor layout. A semi-indoor substation refers to one where, except for the main transformer, the remaining distribution equipment is concentrated in a production complex building. It not only combines the advantages of indoor substations in saving land area and harmonizing with the environment, but also has relatively lower construction costs. It is suitable for construction in economically developed small towns, due to the highly integrated layout, which places live equipment in one building. The electromagnetic and noise impact on the surrounding environment are much lower than those of outdoor substations. But please rest assured that no matter what form a substation takes, it is the optimal choice tailored to local conditions. It must not only provide continuous and stable electrical energy to surrounding users, but also ensure that the surrounding environment meets national standards and absolutely does not cause environmental pollution.
Well, by watching this video, we have learned about the characteristics and applicable scope of substations. Next, we will learn the second classification method, classification by function. They can be divided into hub substations, intermediate substations, regional substations, and terminal substations. Let's look at hub substations. They are located at the hub points of the power system, gathering multiple large power sources and high-capacity tie lines in the power system, and connecting multiple large power plants and large regions in the power system. They are generally suitable for ultra-high voltages ranging from 330 kilovolts to 500 kilovolts. The status of hub substations in the system is very important. If a full station blackout accident occurs, it may cause system splitting or even a system collapse, leading to a disastrous situation. Therefore, in our work, we must develop good professionalism, dedication and job commitment, diligence and attention to detail, and have an overall perspective, especially since substations and the power grid are part of a nationwide chess game. Second, intermediate substations. The high voltage side is connected to hub substations, mainly with through power, and they play a role in exchanging power in the system or segmenting long-distance high-voltage transmission lines. They generally gather 2 or 3 power sources. Such substations mainly serve as intermediate links. Their voltage levels are mostly between 220 kilovolts and 330 kilovolts, which falls within the high voltage range. They supply power to multiple regions and connect some small and medium-sized power plants. If a full station blackout occurs, it will cause regional and grid splitting, and the impact is relatively significant. The third type is regional substations. Their main task is to supply power to regional users. They are the main substations in a region or city, generally suitable for voltage levels of 110 kilovolts to 220 kilovolts, which also falls within the high voltage range. If a full station blackout accident occurs, it will cause a blackout in the local region or city. The fourth type is terminal substations. They are located at the end of transmission lines, close to the load point. The voltage on the high voltage side is 110 kilovolts or lower, such as 35 kilovolts. After being stepped down by transformers to 6 to 10 kilovolts, it is directly supplied to users. This is the substation closest to us users. If a full station blackout occurs, only the users supplied by it will experience a power outage, and the impact is relatively small. However, operations must still be performed according to regulations, and safety awareness must be maintained. Develop good professionalism and a spirit of dedication and job commitment, and must avoid power outages and personal injury accidents. Of course, no matter what method a substation adopts, it is the result of local optimization. It must not only provide continuous and stable electrical energy to surrounding users, but also ensure that the surrounding environment complies with national standards and absolutely does not cause environmental pollution. Next, let us track the development of substations. With the continuous iteration of modern technology, smart substations are also developing rapidly. We know that smart substations have similarities with conventional substations, but also differences. First, the functions they achieve are the same. They are both power facilities in the power system that transform voltage, receive and distribute electrical energy, control power flow, and adjust voltage. They connect grids at various voltage levels through transformers. But at the same time, smart substations and conventional substations also have obvious differences. In the era of smart substations, the cables between primary equipment and protection and measurement and control in conventional substations are replaced by optical fiber. The DC and AC signals transmitted in cables are replaced by signals transmitted over the network. The hardware circuits such as relays used to implement protection logic in the past are replaced by software programs and microprocessor-based protection devices. So, what benefits can smart substations bring us? For example, when the power grid operation mode changes, the system will adjust its operation mode according to the optimal principle. When operational equipment is about to have problems, the system will issue an early warning and provide the equipment's status parameters. When a fault occurs, the system can quickly isolate and handle the fault. After the fault is eliminated, the system can promptly restore power supply. That is to say, the comprehensive construction of smart substations enhances the reliability of electricity usage for ordinary people. The construction of smart substations and smart grids is a crucial choice in the global energy sector for technological development and infrastructure optimization. Smart substations have outstanding advantages such as more advanced technology, more reliable power supply, more integrated equipment, low-carbon production, and more environmentally friendly operation. Well, that's all for today's learning content. Please use your after-class time to complete the post-lesson tasks in the form of group work. So what is the task? Explain whether there are any ultra-high voltage UHV substations in your area. How many kilovolts? How many substations are there? What types do they belong to, respectively? That's all the content of this lesson. Thank you, everyone.